Hello, I'd like to talk to you about my poster presentation on reading aloud between lines, investigating the influence of eye-voice coordination on eye movements at line boundaries. Developing readers struggle to transition from one line to another when reading passages. For example, studies show that grade 2 children do not speed up at the end of lines, which we find in adults. During oral reading, children are less fluent and stumble more at line boundaries, especially when the end of the sentence does not coincide with the end of the line. These difficulties could be associated with the additional demands associated with oral reading, storing words in working memory for later articulation. This additional constraint has been measured using the eye-voice span. The eye-voice span is the distance between the eye and the voice when we read out loud. Single line reading studies show that the larger distance between the eye and the voice during oral reading is associated with longer fixation durations in skilled readers. However, no studies have examined this relationship in children or even by considering fixations along line boundaries. We investigated this by examining 51 children and 52 adults while they read two-line passages aloud, while their voice was recorded and eyes tracked. We merged these two data streams together to identify what phoneme participants were articulating at the start of every fixation. To understand the relationship between the eye voice span and eye movement control at line boundaries, we compared the line final fixation and line initial fixation to interline fixations or within line fixations. Line initial fixations could either be accurate when the following fixation proceeds in the reading direction, or they could be undersweeps. This is when the following fixation proceeds against the reading direction that is to the left in English language. These fixations are often corrective and thought not to be under any cognitive control. We examined how the eye voice span at the start of each fixation type impacted the duration of that fixation. What did we find? An increase in eye voice span resulted in longer interline fixation. And in children, we found that this effect was greater for fixations along line boundaries, so line final fixations and undersweep fixations. However, the interaction was only marginally significant for accurate line initial fixations. We replicated the fixation type effect for all fixation types, but not for line final fixations, indicating a null speed up effect at the end of the line during oral reading. The adult data showed a similar pattern of spatial eye voice span effects on interline fixations, and we also showed significant interactions between the spatial eye voice span and all fixation types. We also replicated the fixation type effect of longer accurate line initial fixations, shorter undersweep fixations, and shorter line final fixations compared to interline fixations for adults reading aloud, which is similar to what we find in adults silent reading and children's silent reading. So what does this all mean? Adults and children show greater eye voice span effects on line final fixations more than interline fixations, and this reflects higher cognitive demands during return sweep planning compared to intraline circuit planning. Accurate line initial fixations display an opposite pattern, as you can see here, suggesting that regressions rather than increased fixations may reduce the eye voice span for such fixations, especially for adults. The effect of the eye voice span on undersweep fixations was greater for children, but smaller for adults, reflecting the possibility that these fixations are under some cognitive control. The take-home message here is that line boundaries may present a unique challenge for children who primarily read aloud, and further research is needed. Thank you for listening.